Okay, good evening everyone. I hope you can hear my voice. Am I audible?
Yes, please.
Okay. So, good
Video
evening.
is also okay.
Okay. Good evening everyone. So, today we are going to discuss on the week 7 lectures of the subject subsurface exploration importance and techniques involved. I welcome you all. I am Balram Shah, the PMRF TA for this course. I am doing my PhD at ICVAR at IIC Bangalore. So today we'll be discussing about the if you have any doubts about week 7 lectures and some of the assignment questions, dummy assignment questions. So let's start. So before moving on to the questions, what all we have discussed in the last lectures, we have started the offshore environment or the subsurface exploration or the investigations about the offshore environments. So in the last class, what we have discussed about what is offshore environment, and we have discussed about the continental drift theory. Then we have discussed about the all the what are the crust, mantle, and all in the earlier lectures, and the how the continental drift theory works and why it is important. What are the important terminologies in case of offshore environment like continental slope, continental margin, then continental shelf, then abyssal plain, continental rise, and then what are the trenches, then sea mounts, and all the important terminologies that are there in the offshore environment. We have discussed that. Then we moved to what are offshore structures, why we build offshore structures, why do we need offshore structures, then why we need the investigations or the subsurface exploration of the offshore environment, and what are the differences between the offshore structures and the investigations with that of the onshore. In offshore, what we have seen, there are several offshore structures such as artificial lands, then support ports, airports, heavy industries, several kind of offshore structures nowadays we can see, like wind turbines that are erected in sea, which are a very good source of energies. Then how the offshore structures or the offshore investigation is different from the onshore investigations, what all we have discussed in the onshore environment in the earlier lectures, and how the offshore environment or of the offshore investigations are different from those, and what are offshore construction, what all hazards can happen in offshore structures. Then what kind of considerations we have to consider, like ecological consideration, what are the considerations we have to do when we are going for sea floor, and then what kind of challenges we have to have, such as the several gases will be there, then sour gas fields, what type sand dunes and all can pose some challenges. Then what kind of sediments will be deposited based on the land mass, based on the marine origin. Then these type of things we have discussed in the earlier class. Then after that also, what all we have discussed, that why the investigation of the offshore site is very necessary, and why we are doing this offshore subsurface exploration, and what all techniques we are going to use. Then after getting the information from the offshore investigation, what we can do, then we can do the preliminary survey and all. For that, what we have seen, that we have to do for before the detailed investigation or in the planning process, what we have to do, we have to go for the planning survey, sorry, preliminary survey, and which will be based on several let us say old studies that has been done In that, what are the objectives of the geophysical survey we have seen. What we have seen, what is bathymetry, what is eco sounding, why we do bathymetry. We have seen that bathymetry we are doing to determine the water depth, the 3D imaging of the seabed, then what kind of some, let us say, some obstacles are there, how to deal with that, and what is eco sounding, what is active system, what is passive system. And then we have seen what kind of profiling will be there, and what kind of equipments we can use. So after that, today we are going to uh, dive in more into that. And as I said in the last lecture, that in some lectures only this offshore structures and offshore investigation, it will not be that much justifiable for this, because offshore structures on its own is a very vast subject. So we are going on the on the uh, very vague kind of thing. Okay, so what we are going to discuss today will be the week 7 lectures. Okay, so first question for that is, deep geotechnical investigation in offshore environment consists of in situ investigation and sampling of soil from the depth of. So what kind of at what depth we are using this, the deep geotechnical investigation, where we are doing in the offshore environment? Anyone?
Option B.
Option B, 120-meter below seabed. Yeah, correct. Okay, so before that I need to explain something. Yeah, it's correct. It will be 120-meter the below seabed. Okay. So before that, let me, why we are doing this geotechnical investigation, because in the last lectures what we have seen up to the geophysical survey, isn't it? So let me switch off this and I'll start here. Can you see that? Hmm, okay. Can we increase this? We can't increase this. Yeah, correct. Okay. Hmm. So what we have seen, we were discussing about the geotechnical investigation in the offshore environment. Geotechnical investigation, and how this geotechnical investigation is different from the geophysical investigation.
Geotechnical investigation is specific to a location,
Mm-hmm.
whereas geophysical survey covers vast areas and vast depths.
Yeah. So
Literally, all.
geophysical investigation, why it covers vast areas? Because in geotechnical investigation what we do, at a specific location we go for some kind of boring, drilling, or some kind of geotechnical aspect of investigation. Whereas in physical investigation, what we have seen some methods like electrical resistivity survey, then seismic reflection and refraction survey, magnetic anomaly survey, and all. So in that, what we can see, not only at the location where the equipment is fixed, but wherever the waves are going, and we are taking the receiver from one point to other, and then from one point to other, and we can have the observation at different locations. And hence geophysical survey and geotechnical survey are kind of different, like in this form. So why we do this geotechnical investigation? So any exploration, as we are seeing, that we are doing this geotechnical investigation or geophysical investigation to access the nature of the seabed materials in terms of its strength, its suitability of the for plant structure. Okay, so why we are doing, to access the, anyway we know this, but still, to access the nature of seabed material in terms of its strength and suitability. plant structure. And other than that, why we do, firstly we need to understand what kind of seabed material is there, then is it suitable for the structures that we are going to impose, then what kind of soil type is there, so that we can understand what kind of possible foundation we can do, possible foundation options, let us say. Then what are the challenges that we can have if we start the offshore construction. So challenges in future. And then also to ensure the safety during the design life, because if we don't know that what is the nature of the seabed and what kind of challenges that we can have during the construction, and what kind of foundation we can lay, after knowing all this we also should know what is the safety precautions, that whether this offshore construction or offshore structures that we are going to impose will have safety during the total design life that we are considering. So the fourth will be to ensure the safety of the structure during its design life, during its design life. Okay, so for all this consideration we are going for geotechnical investigation, and while going for geotechnical investigation, what we need to do, we need to do the planning. As in the last lecture what we have seen, for the proper planning of the offshore structures, what all investigations we have to do, we may have to do the preliminary investigation, preliminary investigations. So preliminary investigations, as in the last lecture we have seen that those are based on the available reports. Let us say someone has done some test beforehand and they have prepared some reports, so studying those reports we can understand, or we can have some idea about the location that we are going to see, some maps or the some published data that are there for the site. So firstly is the preliminary investigation. Next, what we have seen in the last class was the shallow geophysical survey. What kind of shallow geophysical survey we have seen? Up to this we have studied in the last class. What are the shallow geophysical survey we have seen?
Echo sounding, etc.
Yeah, echo sounding, bathymetry and all. So those this kind of survey is required to provide information required to plan for the detailed geotechnical testing. So why we are going for geophysical survey? First of all, anyway we are going for the understanding the strata and all. But one more thing is, because the geophysical investigation, as we are doing in the offshore environment, it will be like if we are going for geotechnical investigation directly, it might be expensive for us. So one of the main advantage of geophysical survey is that if we do the geophysical survey, we will understand that whether we need to plan for the detailed geotechnical investigation or not. So the shallow geophysical survey, other than all the things that we are doing, it also provides the information that whether we need to plan for detailed geotechnical investigation or geotechnical testing, which are like costlier than the geophysical investigation. These are the shallow geophysical survey. Then comes the shallow geotechnical investigation, or the shallow geotechnical survey. So in the shallow geotechnical survey, what we do, we collect the samples from few meters below the seabed. Why? To understand or to examine the properties for the lab tests. Like let us say we are going to lay some pipelines through the seabed, or some small offshore structure we want to build. So for that we don't need to go for the deeper geotechnical investigation, because that is not needed anyway. So let us say we are going to lay some pipelines for the sea floor. So for that we need only shallow investigation or the shallow geotechnical investigation. So for that kind of thing we go for this shallow geotechnical survey. Okay. And other than that, sometimes for big structures like wind turbines, then some big structures if we want to build like bridges, airports and all, then we have to go for the deep geotechnical investigations. So in deep geotechnical investigation, or what we do, as we have done in the onshore investigations, like that kind of thing only we will do. That mostly same kind of tests we are using in the onshore offshore environment also for deep geotechnical investigation. So it will consist of in situ investigations as well as the sampling from larger depth. Let us say in the last questions what we have seen, it can be 120 meter or more, 120 meter or below the seabed. Okay, I'll write 120 meter or more below the seabed. Okay, now the we'll do the in situ investigation also, and we'll collect some samples also, and after collecting that samples we'll go to the lab, we'll do the lab investigation also. And generally we'll do this using some fixed platforms and mobile platforms. The platforms and all we'll be discussing later. Okay, so let us come to the questions. Okay. So the question was what? Deep geotechnical investigation in offshore environment consists of in situ investigation and sampling of soil up from depth of. This we have seen, it was 120 meter below the seabed. So it was correct. Next question is the planning process before the offshore structure requires option A, shallow geophysical and geotechnical survey, preliminary investigations, deep deep geotechnical investigations, or all of the above. What will be the answer?
A.
Okay, anyone? The whole planning process I'm talking about.
All of the above.
Yeah, because see, I'm talking about the whole planning process. So in the whole planning of the offshore structures, we have to go through all of this. Because if it is like not small offshore structures or pipelines, but the whole a big offshore structure I'm talking about. So if we are talking about big offshore structures or normal offshore structures, then for the whole planning purpose, what we have to do, we have to first go for this preliminary investigations, then we have to go for shallow geophysical and geotechnical survey if required, and then deep geotechnical investigation. So it will be all of the above. Okay. Okay. So next question is the sample collected by using dash can be used for strength determination. So now we'll come to the collection of the sample. But before that, the collection of the sample, when we'll go for, if we are going for shallow geotechnical investigation, that time also we have to collect the sample. And if we are going for this deep geotechnical investigation, then also we have to go for sample collection. Now in the case of shallow geotechnical investigations, what we do, we generally limit it to few meter depth, as I said, below the seabed, not below the seawater, because that after the seawater the seabed starts, and then only we need to know the stratification of the layers. So we'll go few meters below the depth of below the seabed to when we are going for shallow geotechnical investigations. Now for this, specific drilling assembly is not required. Like you can very small things, very small assembly we can use to take out the sample, because we are doing only for few meters. So specific drilling assembly is not required, like we have to drill and then we have to put it out, not like that. So samples of the seabed soil and water will be collected for environmental baseline survey, and then for pipelines if we are going. So kind of it will not take much time, because we will take it will take around few hours in sampling, and then the sampling or the vessels that we are using for sampling. For before that we need to understand what is vessel and all. Okay. Okay, so what we were discussing where. Okay. Shallow geotechnical investigations. So what I said, in shallow geotechnical investigation we go only for few meters. I'm not writing much, sorry, few meters. Then drilling assembly and all are not required. But even if let us say we are going for some drilling assembly, then what we need one vessel or ship kind of thing. So this vessel that will be used for sampling should be anchored from all the sides, so that there should no lateral movement, no vertical movement. Otherwise what will happen, the sample that we are extracting will get disturbed, right? So the vessel that will be used for sampling must be anchored. Anchored means you understand, right? It should be hold tight at uh, at number of locations, minimum like 3 or 4 we need, in order to avoid any possible movement, like horizontal movement or vertical movement or sidewise movement during the sampling. So it will as I said, in which kind of survey we'll do this, let us say for pipeline survey or pipeline route laying. Then other than pipeline laying, if there are some small offshore structures we want to build, then we go for this kind of geotechnical investigations. So mostly it will be conducted at a far interval, let us say at 1 kilometer or some 1 kilometer or more than that it will be uh, done. Like if some studies had been done before that for that location, and then also we can go through that report, and how much we need we can go for that also, like at what interval we need to do these tests. Or if experts are there, they can also give some idea that at what intervals you have to do this. So mostly this vessel that will be there, let us say if we are making the plan of the vessel, so this kind of, let us say, vessels are there, so it should be anchored from all the sides. Okay, it should be anchored to all the sides, so that there should not be any possible fluctuations, let us say in the horizontal direction. And again it should be anchored with the seabed or some kind of structures also, so that there should not be any vertical, like minimal fluctuations should be there. That kind of um, um, that kind of arrangements we have to make. So there should not be any like this kind of fluctuations or this kind of sideways fluctuations, or there should not be any vertical. So okay, I'll write it here: no lateral movement. This is vessel, so there should be no lateral movement of vessel. Or let us say like in what all reasons can be there because of which this movements or these fluctuations can happen. why this fluctuations, why we need this anchoring, because there should not be any fluctuation. But how this fluctuation can happen if we don't do this anchoring, whether there will be any fluctuation? If yes, why, like, or how?
Wave action.
Yeah, there can be wave actions. So there can be wave actions. So from this wave actions, there should be minimal change in the vessel, minimal change in vessel positions should be there. Okay, similarly vertically also, this vertically also minimal fluctuations should be there. Okay, now for this kind of investigations, what I said, we are going for sampling. We are going for sampling. So for shallow investigations, the type of samplers that we use are grab sampler, then box sampler, then drop sampler, then vibro core sampler. We'll be discussing all this. Then piston core sampler, and several other samplers can be there, drilling samplers and all can be there. So first of all we will discuss about the grab sampler. So in grab sampler, like what kind of sampler is this? Like there will be one spring that will be loaded with the clam shells. Okay, I have one figure, I guess. Wait, let me show you. Yes, we have. Okay, so what is grab sampler? As I said, that this grab sampler will consist of spring loaded clamshells jaws in pair, and at the test location, what we'll do, the sampler will be lowered till the seabed, where we need to do the sampling. And once it is getting contact with the seabed, the jaws that will be there, which are open like this, while lowering, what will happen, it will get shut. And then as it will get shut, what will happen, the materials or the uh, or the sample that we need will be contained in that. And what we'll do, like this type of clamshell jaws will be there, and it will get closed like this. So what will happen, a scratching will be there for few inches of soil, and it will contain the sample. Okay, okay, we'll show you. This is the clamshell jaws. Okay, let me do that. Pointer. So see, these are the clamshell jaws. If you see it properly in this, so what will happen, this will be lowered like this, and once it is getting contacted with this seabed, what will happen, will lose this out, and what will happen, this will get closed. Okay, and this will get closed. So what is happening in this will scratch the seabed, some kind of some part of the sample, and what will happen, it will get closed, and the sediment or whatever the samples that we need will be getting contained in this, and then it will be pulled out. And upon withdrawing the sampler to the vessel, the sample will be collected, and the samples which will be obtained this way, what will happen, okay, so one GIF, say here, how, what kind of thing is there, these two are the clamshells, and it will get closed like this, and after getting closed, we'll pull it out and we'll get the samples. So the samples that we'll get in this sampler, what kind of sample it will be, like proper
Disturbed.
yeah, it will be highly
Disturbed
disturbed
sample.
sample. Why? Because we are scratching the sample and then we are collecting it. So it will by no chance it will be undisturbed, because it is getting disturbed as we are getting scratching in that sample, so it will be highly disturbed. And thus for what kind of thing we can't use this kind of sample? For, let us say, for understanding the strength, for determining the strength of the soil, we can't use this kind of samplers. Okay. Okay. So next, after this grab sampler, what we have seen, we have the box core sampler. So in box core sampler, there will be one kind of box. Okay, we have the pictures for that also. So see, in this is one kind of box. This can be made of metal and all. So this is kind of metal. Okay, so this is the box that we are referring here in the box core sampler. So it will be consisting of a box with the bottom open. So here if you see from the bottom, then you will see that it is a open structure. So what will happen, a box is like this and here it is hollow. Okay, and this will only collect the samples. So upon lowering on the seabed, see in this picture, if you see, this is the box, and what we'll do, we'll lower it to till the seabed. Now what will happen upon lowering at the seabed, it will penetrate a few meter up to whatever length or up whatever height we want, based on the box height also. It will penetrate few inches into the soil. Now okay, now cutting plates, that will be provided at the bottom, like in that box at the bottom there will be cutting plates, and the cutting plates that are provided at the bottom, which were actually in the locked condition first. While lowering the samples, those will be released. See, this one is the cutting sample. Okay, so what will happen, if we first we'll keep it like this. Now if we lose this string, okay, and this string is called draw wire. Okay, if we lose this string, what will happen, this cutting edge will get into this. And uh, just think that what will happen if we are losing this draw wire, the cutting edge will come uh, like this, and then it will cut the sample, and it will get contained in the box, because first the box will penetrate. Now this will come and cut, and then what will happen, in whatever length or height it has been penetrated, that will be contained as the sample. Okay, and this will be released by some mechanical system. Here we'll do something, and then the cutting the sample from the bottom, the sample and then it will be lifted out to the vessel. And once the soils are lifted, you can do the tests and all. So in this, let us say, the grab sampler and that we have seen, and the box core sampler that we are seeing, what do you find difference, like what kind of samples we'll get, whether the yeah,
Disturbance will be less
less in which one?
in this one,
Yeah, in
box
box core
core sampler.
sampler, it will be less disturbed than the the grab box. And it can be used for the determination of density, it can be used for the determination of moisture content, as well as the strength of the soil in the lab, because it will be less disturbed than that of the grab sampler. So I'll draw this box core, but I need to name it out, what are the names of all this. Okay. Yeah. Hmm. So grab sampler we have discussed. Then we were discussing about the box core sampler. So what we have seen in the box core sampler, let us say here the vessel is there, and this is the lift, some kind of weight column will be there. So this is the weight column, and as you have seen there, some kind of wires are there. this was the cutting edge, or you can see the mechanically controlled cutting assembly, as you have seen in the figure. Okay, and there were wires which were connecting this like this. So these are called the draw wire, and here there will be one water vent, and here there will be one box in which the sample will get collected, and here the seabed will be there, seabed or sea surface, whatever. The box will get penetrated, this cutting edge will go like this and will get a sample, and it will be less disturbed than that of the grade. Okay, so here in this, let us say we got here, so here we will get the sample. Okay, so box core sampler we understood. Next is what? Grab sampler done, box sampler done. Next is the drop sampler. Okay, okay, sorry. So box core sampler we have seen. Now this box core sampler, after this what was there? It was, okay, before this it was drop core sampler. Okay, drop core sampler we have not, figure is not there, so I'll discuss that there. So other than the what we have seen, wait, you can see the figure. Okay, so grab sampler we have seen, box sampler we have seen, then we have drop sampler, then we have drop sampler. So in drop sampler, simply there will be one steel tube and it will be hollow. Okay, it will be like one tube will be 6 to 8 meter length with the like some 100 meter of 100 millimeter of outer diameter will be there, with some kind of 80 to 85 millimeter of internal diameter, and there will be cutting shoe at the edge. Okay, so what I was saying, so in the drop core sampler, what will be there? It will be having one hollow steel tube with 6 to 8 meter of length and 100 millimeter of outer diameter and 85 millimeter internal diameter, and it will have one cutting shoe at the lower end and a core catcher at the tip. And so what will happen with its self weight only? What will happen, it will be dropped, the core will be dropped from the vessel, and because of this impact load, what will happen, it will penetrate into the seabed. Okay, so we have the, I can't drop my pencil. So let us say we have the drop core, will drop the will drop the core from the vessel, and what will happen, because of its impact load, the weight for it will be 800 to 1000 kg. Weight will be around 800 to 1000 kg. Okay, weight for the drop core will be 800 to 1000 kg. Now with its load, what will happen, it will go up to the seabed and it will penetrate because of the impact load, and then we'll get the sample, and by means of the core catcher and the cutting shoe, it will again will bring to the surface, and then we have the sample. Okay, then other than the drop sampler, what was there? The vibro core sampler was there. Okay, so next is the vibro core sampler. Okay, so in vibro core sampler, what will be there? The mechanism, whatever is there, it remains same as the drop code. Like one code will be there, and it will have the cutting issue and the this core catcher will be there. However, what will happen in this, in the vibro core sampler? Okay, we should increase this. So in this, what will happen? Rather, this impact load due to the self weight, it is penetrated in the seabed against electrically driven vibrator. In that, what will happen? It was because of its self weight only, it was getting dropped and it was collecting the soil sample with the setup. But in this, what will happen? We'll give one electrically driven vibrator. Okay, and thus it can be driven into harder soils also. Let us say in the seabed, not only the soft soil, but we have the harder soil. Then what we'll go for? We'll not go for drop core, but we'll go for the vibro core sampler. Okay, so as we'll do this, this electrically driven vibrator will be there. It will be driven into the harder soil, and we can have the samples. So both drop core and vibro core will provide what kind of sample, whether it will be undisturbed, whether it will be disturbed or highly disturbed, what kind of sample will get?
Highly disturbed.
Yeah, because what we are doing, we are giving, like we are dropping the core from a very high depth or high height. So that's why impact load is given on the soil and it is getting highly disturbed. What was saying? Electrically driven vibrator will be there in this case. Okay, then we have the seabed piston core sampler. Okay, in this there will be one piston assembly. Okay, we have one picture here. So next is the piston core sampler. So in piston core sampler, what will happen? We have one piston assembly. Piston, this type of assembly will be there. So a relatively undisturbed sample will be obtained from this, from the seabed. But how we are doing this? See, here we can see there is one sampling tube. Okay, this sampling tube will penetrate into the seabed and it will collect the sample. And in the top, if you can see properly here, okay, whatever, so in the top, what you can see, there will be a piston, and this piston will create a suction pressure. And this suction pressure, first we are penetrating this tube, the sampling tube, and now the sample is in the tube. Now the piston will create a suction pressure, and because of that, the whatever the sample is there, it will be intact in that, because we have created a suction pressure, and for that pressure the sample will not fall off. So it will retain the sample into the core, and this way the full core recovery with minimal disturbance is possible without withdrawing to the surface. Okay, so in piston core sampler, what kind of sample we are getting? We are getting very good, like very undisturbed. We can't say no sample are fully undisturbed, but with minimal disturbance we'll get in this. So what happens? See, okay, here this sampling tube is there, it will be penetrated, then one kind of suction pressure will be given, and when we are pulling it out, because of the suction pressure, it will retain in the sampling tube. Okay, so this one is one piston core sampler. There can be multi piston core sampler also, that they see there can be several sampling tube, and it can create pressure. So this one was piston core sampler. So what kind of soil we are getting? We are getting some kind of undisturbed sample, or we can say minimum disturbance has been created in this soil. So we can use this for any kind of tests. Okay, so these are some of the samplers that we use. So what was the question? Sorry. So the question was, the sample collected by using dash can be used for strength determination. Our options are grab sampler, drop core sampler, vibro core sampler, and seabed piston core sampler. First of all, to have the strength determination or to determine the strength of the sample, what kind of soil do we want or what kind of sample do we want?
Undisturbed
Undisturbed. So undisturbed or minimal disturbance should be like
or minimum
yeah.
distance.
So which sampler should we use?
D appears to be the correct answer.
Yeah, because see, in the grab sampler also we have the scratching thing, so it will create disturbance. In the drop core and vibro core, the it will be dropped from a distance or electrically driven this uh, arrangement will be there. So all these first three options will give you disturbed sample. So you can't use it for strength determination. In piston core, we get very minimum disturbance in the sample. So the correct answer for this will be seabed piston core sampler. This all we have seen. Okay, so next question is which among the following samplers will get penetrated in seabed due to its self weight alone? So your answers are this.
A.
Sure. In vibro core sampler we drop
Both
only.
A and B.
Yeah, because in vibro core sampler after dropping what we are doing the electrically we are driving with the electric. So in drop core and vibro core, in both the cases, it will be dropped because of the self weight, but the sampling will be in different methods. So what is the question? Which among the following samplers get penetrated in seabed due to its self weight alone? So it will be both the drop core and vibro core sampler. Okay, am I clear?
You only one option, then both A and B. C is available, right?
Yeah, correct. Okay. So, oh wait. It should be C. If self weight will be there, wait, let me check once. It should be self. Just now we have discussed, no? For other impact due to self weight, it is penetrated in the seabed against. Okay, no. So no, in vibro core sampler we don't go for only self weight. We are going for electrical driven vibrator also. So I'm sorry for the thing. When I discussed about the vibro core, that time only I discussed it is not only it is not based on the self weight, but we are also using the electrically driven vibrator. Okay, so the correct answer will be drop core sampler. I'm sorry for that. Okay,
Yeah.
can I move? Okay, thank you. Sorry. Okay, so next question is which of the following sampler will provide a lesser disturbed sample than the others? This will be simple. Grab sampler,
Box
box.
score.
Yeah, correct. Box score, because all of them will be much higher disturbed. Next is strength properties of the seabed material can be determined when it is collected by means of dash sampler. Out of this option,
Box score.
yeah, box score, because it is less disturbed. Correct. Simple question. Which of the following is true for the drop core sampler? A drop hammer is used for the penetration of the sampler. The samples from the drop core can be used for strength determination. Drop core samplers get penetrated in seabed due to its self weight.
Option C.
Yeah, drop. Yeah, yes. Option C will be the correct. Because see, the first option is drop hammer is used for penetration. In this, no drop hammer is used because of its self weight only. It is getting penetrated. Second is the samples from the drop core can be used for strength determination. It can't be used because it is giving highly disturbed sample. So the correct answer will be C. Okay. So next one is in seabed, dash can be used to determine the strength of the seabed material continuously at every depth. It is the in seabed, dash can be used to determine the strength of the seabed material continuously at every depth. Okay. So before that, we'll discuss when we'll move coming to this. Okay. So after the sampling, what we have to do, we have to go for the in situ investigation, or let us say we have completed the shallow geotechnical survey. Then what we will go for? We will go for, it is working now. Deep geotechnical investigation, or the in situ investigation. So we'll go for in situ investigation. So mostly whatever test we'll be doing for the geotechnical investigation at deeper depth, we'll go for most of the tests that we have done in the offshore investigation. We'll use those only. What all tests we have done for geotechnical investigation in deeper depth in onshore investigation?
We have wind shear test, CPT, DMT, etc.
Wind shear test, then standard penetration test, cone penetration test, then pressure meter test, then dilatometer test. So I'm not going deep into the test because we have discussed about all those tests. So mostly this strength determination in offshore is possible using the CPT, wind shear and dilatometer test. Wind shear test, we know it will be very much useful for the very soft soils. In wind shear test, what we do, the vane will be pushed into the seabed, the torque is required and the corresponding rotation that is required for the giving that torque will be measured for the strength determination of the material, and mostly very soft soil will be used for wind shear test. Okay. And then what we have for CPT test, two widely followed methods will be including. First one was the cone will be penetrated into the seabed by means of wheel driven assembly, which will be first lowered to the seabed from the vessel, and upon rotation of the unit, the CPT rod will be pushed into the seabed. Okay, this one will be wheel assembly. Second can be in this assembly, what we'll do, CPT rod will be consisting of a tube, and it will be wound around a circular frame. Okay, and for penetration, the reel is that wheel is will be rotated, and thus the wound that will be there, it will get unwounded. Okay, unwounded the tube, and then the CPT assembly will be pushed into the seabed, and after that is contacted with the seabed, the tube will be first straightened before pushing into the seabed, and then with the cone penetration test, what we get, two things we get.
We have tip resistance and side friction, sleeve
Friction. So what we get the cone tip resistance and the sleeve friction as well. Okay, as well as pore pressure also. Okay, so sleeve friction as well as the pore pressure are done at every test depth. It is almost similar to the onshore investigation. Then comes the dilatometer test. The dilatometer test will be mounted on the jack-up platform. The platforms that I am discussing will be discussing in coming slides. So it will be mounted on the jack-up platform, let us say, and it can be used for offshore investigation, like what we have done in the onshore investigation. In case of let us say barge, a guide tube will be provided to compensate for the whatever the fluctuations will be there due to the water waves. In that, a guide tube will be there. Further, while taking the measurements, the pushing rod should be disconnected. Okay, and the pushing rod that is there, it should be disconnected from the pushing assembly, so that no movement should be there while taking the measurements. Okay, in the dilatometer test, it can be performed from the seabed also. Okay, a steel frame which is anchored to the seabed, and the steel plates will be provided within the steel frame to provide the resistance against the rod push. Okay, so these are the dilatometer tests and all the tests. These were the in situ investigation. So in this, what we were discussing, that a vessel will be there. So this vessel, if I draw, or the vessel layout if I draw, so this vessel layout will have so many things, or vessel will have so many things. Okay, it will have one drilling deck or derrick, something they call. So drilling derrick, in which from at that position only that drilling rod will go and drilling will happen. So there will be one drilling derrick. Okay, so this drilling derrick will consist of a frame tower. Okay, first let me draw the setup. Let us say, okay, take some other color. Let us say this one is our vessel. Okay, so there will be one drilling derrick will be there, let us say. So this one is the drilling derrick. The function of all this thing I will come. So there will be one drilling derrick will be there. Then let us say some pipe racks will be there. Then helipad will be there. Then moon pool will be there here or somewhere else. And there can be some towers for communication, some radio towers or some kind of communication tower should be there. Communication assembly should be there. Then several this kind of things will be there for the vessel layout. So first one was most important is the drilling derrick. So what is this drilling derrick? This drilling derrick will consist of a frame tower. So one frame tower will be there, let us say 20-meter height or so, which will be located at the center of the vessel, and from there only that rod whatever we are pushing down will be coming from there. That will be drilling derrick. Next I showed was the moon pool. What is moon pool? Moon pool is a hole which will be under this drilling derrick to lower the drilling rod and assembly to the seabed from the vessel to facilitate drilling. Okay, I'll draw it once. So drilling derrick, as I said, will be a frame tower that will be located at the center of this vessel. Then what I said, moon pool, sorry. So moon pool is a hole at the drilling derrick or under the drilling derrick. From there only the drilling rod whatever assembly will be there, it will be lowered into the seabed to take out the samples or facilitate drilling and all. Next we have the pipe rack. So this pipe rack will be there to keep all the drilling rods which we are using to drill or getting the samples. So it is kind of to stack all the drilling rods and all. Then we'll have mud tank or mud mixing tank. Mud mixing tank will be there to like, because we are drilling, so there will be some fluid in onshore investigations also. What we have seen, while we are drilling there will be some kind of fluid that will be coming out. So to store those drilling fluids, to we have this mud mixing tank. Okay, then we have communication and positioning system will be there, or assembly whatever you say, to communicate. Then we will have the powerhouse. Then we'll have one kind of place where people can stay also, all that thing. Okay, that I'll show. I have one picture also. Then we'll have lab where we can do the simple small tests. Then we'll have the heave compensation assembly. What is this heave compensation assembly? The heave compensation assembly will be there to ensure the drilling cable will undergo relative movement with respect to ship. Because let us say we have a ship and we have that drilling cable is undergoing, so there will be a one relative movement. So to ensure the drilling cable undergoes this relative movement with respect to ship, we have this heave compensation assembly. Okay, which will compensate the if there is any relative movement between the ship and the drilling cable, that will be compensated by this assembly. Then we have anchors. In beforehand only we have seen that to have minimum fluctuations, we have to have this anchors to ensure there will be no movement of the vessel while drilling. Because while drilling we can have, because of the drilling, then because of the water waves and all, we can have some fluctuations. So to minimize that, we have this anchors. Okay, I'll show that here now. Okay, before that we'll see these questions. Okay, so the question is, in seabed, dash can be used to determine the strength of the seabed material continuously at every depth.
CPT. D.
Srinath, any answer?
CPT.
Yeah, correct. So the cone penetration test will be used to determine the strength of the seabed material continuously at every depth. Okay, next is, moon pool is provided in a vessel to facilitate. Just now we have seen. What, first of all, what is moon pool? What I said, what is moon pool?
It's a hole in the
It
center
is
of
a
that
hole.
vessel.
Yeah, yeah. So that is provided to do what?
Drilling.
Drilling, correct. Because okay, so mostly answer will be drilling. The circulation of drilling fluid, for this what we use, or to
That
keep that one mud tank was there, mud mixing tank, we use that. And the vessel to remain stationary during drilling, we use the anchors. Okay, so this one, this is kind of the vessel layout that I drew. So see here, here we will have that assembly. This one is the assembly. This assembly is called what? Drilling derrick. Okay, and under that there will be hollow called moon pool. Okay, and this is the pipe rack that we have seen. No, no, this one is not that. There should be one pipe rack. This one is the helipad. Here people can stay, whoever is coming for the expedition. And then we will have frame, we will have cranes and all. And on this we'll have some other platforms also that will coming later. Okay, so vessel layout anyway we have seen. Next question is, which of the following statement is not correct for the vessel layout? So options are, moon pool is provided in a vessel to facilitate drilling. Heave compensation assembly is provided in a vessel to ensure relative movement of drilling cable with respect to the vessel. Mud mixing tank is provided to store drilling fluid, or none of the above. Which is not correct?
Option C.
Option C, mud mixing tank is provided to store drilling fluid. This is not correct.
Option B.
D. D will be there. None of the above. All appear to be correct. A, B, C.
Yeah, because see, mud mixing tank we use to store the drilling fluid. What I said in the heave compensation assembly, in the heave, why this heave compensation assembly is there? Let us say if we have any relative movement between the drilling cable and the vessel, that will be compensated by this assembly. So this is also correct. So all the three A, B, C are correct. So not correct is no one. So it will be none of the above. Srinath, I'm clear.
Yeah, clear.
Okay, okay. Now coming to the platforms. For this, different types of offshore structures are there, isn't it? For the oil and gas exploration and whatever we have seen. So there are different kind of offshore structures, or sorry, offshore platforms that we use when we are going for subsurface exploration, investigations, whatever we are doing. So for that, there are several platforms. So one of those are jack-up platforms, then we have jacket platforms, then we have pipelines, then we have artificial islands. This kind of structures will be there. And what we have seen, that this, for this detailed investigation, we go usually in the water depths of 120 meter or even more. Okay, so first one is the jack-up platform. Okay, so anyway the picture will come later. First we'll understand that why we are using this jack-up platform, and what is the what is the point of taking this jack-up platform. The jack-up platform on its own is a mobile platform. Mobile platform means what? That it can move. Okay, it is a self-elevating unit which will be used for the offshore environment for oil and gas exploration. Generally we use this jack-up platform for shallow water depth. Okay, not very deep water depth. Typically this setup will consist of bow and hull. Okay, in this picture it is very far from here. Okay, I'll draw that then. Wait. So there will be one buoyant hull which will be supported by some tractable truss frames which will be acting as supported legs as you have seen. Okay. Now coming to the jack up platforms, as it is like jack up platforms, this means what, it can be elevated also, so it has one self elevating unit also. Okay, whatever, this jack up platform will be used to have some platform to having that drilling assembly drilling and all we are doing. So for the superstructure there will be one superstructure all, or the hull or the binding system whatever we say. So that will be there so that we can understand the physical condition of the system. Let us say will it be whether it will remain sustainable during its whole design life, depending upon what are the sea environment upon this for every sea environment there will be some different um, environment will be there for all the locations. So based on the sea environment, whether whatever structures that we are creating, whether that will remain okay or sustainable for on the whole design life, that we have to see. Then we have to see what are the bearing strength and settlement criteria for the subsoil or the soil, or the soil which is there under the seabed. Then what is the medium of the final load, water depth and all. Okay, so whatever we were discussing about the jack-up platform. So this jack-up platform, as you have seen there, will be like this one platform will be there, and there will be some 3 4 this kind of structure will be there, and seabed will be there. This kind of 3 4 based on how much big is the platform. Okay, I'm drawing platform. So in this what will happen, there as I said, it is a mobile and self elevating platform. So this platform whatever you can see, this one is called hull or the ship or the buoyancy, because it can be floating also, buoyant ship. So there will be this 3 or 4 ship trusses will be there, okay, to hold it. So these are the trusses, tractable trusses, what I was saying, steel truss. Okay, and this one is the seabed, and here the drilling derrick will be there, and from here that whatever drilling assembly we are putting, so this will be the drilling assembly, this will be the drilling derrick. Okay, and there will be several other things, cranes and all will be there which is required. So this will be self driven, or it can be towed with the pontoons also. So mostly we use this jack-up platform for shallower depth, and it is mostly the cost effective and all. The cost is so much for us. So this kind of platform are cost effective. So as we have seen, 3 4 kind of support is necessary for this buoyant assembly. So as we have seen in that, no, okay, where is that? So here what you can see these are the trusses that we are seeing. These are the trusses, the buoyant ship, or this one is the hull or the buoyant ship. These kind of crane structures can be there. Then what all? So these are kind of jack-up platforms which we use. Okay. Then there is one platform called jacket platform. So this jacket platform was the mobile platform. It can move, but the jacket platform is kind of fixed platform. Okay. So it will also consist of the steel tubular frame, and it will be piled into the seabed. Okay. It will be directly one fixed structure will be there, and it will be piled into the seabed. And small jackets are generally used as the wellhead platforms or the pumping station along the pipeline if we want to install pipelines. And let us say if you want to install some communication units, that also you can install. Then for drilling and production units we use larger kind of jackets. Okay, so I'm not going into the what kind of structures and all are there, because yeah, anyway you guys have seen in those. I'm not going to draw all that. So there will be in that also there kind of fixed structure. Then there will be anchor. It will be anchored at the end at the seabed, and the boat or the ship will be there. As I said, there can be some pontoons will be there. So some boat or ship will be there from which people will come, and let us say there will be one intermediate platform also. So if you want to check that whether it is coming or not, we can go like that. So there will be one fixed platform, one drilling assembly will be there, similar kind of structure. And this drilling derrick will be there from where the drilling assembly will be put forward, and the communication tower if needed for we can install and all that. So first one was the jack-up platform. Next one is the jacket platform. Then we have this pipelines, then artificial islands and all. So why we use these pipelines for offshore structures as offshore structure? Mostly to carry the oil and gas. Okay, from the let us say yeah, in the offshore structures when we are discussing, we discussed that there can be some support ports also. So like that the oil and gas from it can be for very large distance, like for hundreds of kilometers also we can lay the pipes. So it will be laid over on the whole the seabed to carry out the oil and gas, not carry out to the carry the oil and gas from the exploration rig to the shore or wherever you want to like send it. Okay, so there will be okay, I'll draw, there should be one picture. Yeah, so see here, and this kind of pipes will be there. So and there will be here also drilling assembly will be there, here drilling assembly will be there. Then this kind of pipes will lay down like this. So this kind of pipelines will be there. It will transfer that oil and gas from the exploration rig to the shore or wherever you want, shore storage, or let us say you want it to transfer to the processing rig, that also you can do. And let us say here it is not there. Let us say one pipe is laid like this and one pipe is coming like this. So how will it cross this? So there will be some kind of assembly which will go on the top of this, and then it will go like this. Okay, so there can, okay, I'll draw that. Okay, so what I was talking about, the pipelines, we use it for hundreds of kilometers. Okay, hundreds of kilometer from the exploration rig to the shore or production units or processing units, wherever you want you can transfer. Now what will happen, let us say one pipe is laid like this in this direction, and one pipe is coming from this direction. So here it can't interfere, so what will happen, that kind of assembly will be there like this, and then it will go. Okay, anyway it's a straight kind of pipe, so it will go like this. Okay, So this kind of elevation change will be there. And again in that figure also we have seen if the seabed is not flat, if it will also change its elevation, some kind of sea mounts will be there again. The land is like this, and then it again it became flat like this, it has some elevation difference. So for that also we have to take it into consideration. So if we draw that in the cross section, it was plan kind of thing. If we want to draw the cross section, okay, so let us say this is the cross section for the pipe. So in this, what kind of forces will be there? Let us say we have one structure here to keep the pipe. Okay, so there will be soil friction here. Then what other forces will be there?
Drag force.
Drag force will be there at the this, let us say here, the whole pipe, it will be drag force will be there. Then waves will be there, so wave currents will be there. Then the self weight of the pipe will be there, self weight of pipe. Then let us say some oil or gas, whatever is we are transferring. So okay, sorry, so we'll have some lift force also. Then the weight of the, let us say oil is flowing here, so weight of the substance or whatever, let us say oil, whatever is flowing, it the weight of it, those will be there. Okay, so let us say this is the seabed. Okay, let us say some active faults is there. Okay, that I will come in later. So there will be one support system here. So this is the support system. And why do we need this support system? Why do we need this support system for the pipes?
For lateral stability.
Correct. There can for lateral stability, because of the wave current, this kind of this many forces if we are having, there will be so many lateral movements can happen. So for that we need this support system. Other than that, anything? There are some.
Seismic activity is also possible.
Yeah. For holding that also. And again we are seeing, other than the horizontal forces, there are several vertical forces also. So what can happen because of those if the support system is not there? Because
There may
self,
be failure, movement, excessive deflection, etc.
yeah, the settlement can be there, isn't it? So sufficient load bearing stratum should be there to minimize this settlement. So for that support system is used to minimize or arrest any lateral displacement, as we have seen. Then drag force along the direction of flow is there. For that also, and there can be some deflection or some displacement. So for that also we need the support system. So like that, so sand dunes things, as I discussed in the last class. So possible load from the sand dunes can also be there, because it can also lead to some settlement consideration. So for that also we can have the support system. Okay, so for different, for if let us say there are two faults here, active faults. What is active fault and what is passive fault or non-active faults?
Active faults have the capability to induce earthquakes.
Yeah, correct. So when there can be the seismic activity and all, if there is an active fault, it can lead, because if non-active fault is there, it will not lead to seismic activities and all. So this active fault can lead to seismic activities, or very easy to, so it can come out and all. So for that there can be vertical displacement, there can be, let us say two fault planes are there, and it can happen that seismic sources are there with the sea. So for that also, to withstand this kind of possible movement along the fault, we need the support system. Okay, Okay, so we'll move to the next thing. Pipelines and supports you got. And next, other than that, what I said, jackup platform, jacket platform, pipeline supports, artificial islands. So this artificial islands, in the last class also we have seen that it is used as one kind of offshore platform in shallow water. That's why many artificial islands are built. So it is developed for cash and retain platform or some kind of platform. Okay. uh, then we have one buoyant platform. Buoyant platform means which is floating on the sea surface. Okay, so we can have the buoyant platform also, which will be available in various shapes and sizes. Commonly we have this FPSO. We have, you must have came across. Okay, buoyant, spelling is correct, I think so. Buoyant platform. So you might have come across FPSO. What is FPSO? Anyone?
Floating production,
Floating production.
then S stands for
Storage.
storage.
So what we are doing, just remember like this: we have to produce, we have to store, and then we have to offload. And offloading. So if there are several platforms, then we will consider as FPSOs, platforms. Sorry, platforms. Okay, so this FPSOs will be there, because it is kind of ship or the vessel. Processing unit will be there. So usually what will happen, usually there will be oil tankers which will be converted to such units, to such processing units, which will rest on the platform. And it is commonly used in remote locations where not that much thing is used. So what kind of this FPSOs is, what kind of thing? That is one kind of ship or vessel, whatever you say. So there will be one, this floating production is there na. So there will be some production unit, then some storage unit, let us say LS, and some communication unit will be there. So this is production unit, this is storage unit, and this is communication unit. And this should also be anchored in the seabed. And this is seabed. This is seabed. Okay, because to do not allow some lateral movement of ship. And there were FPS is also FPS. But before that, let us do some questions. So what I was discussing.
Questions you wanted?
Yeah. Okay. See in this picture what I was saying, there in the seabed also there can be several elevation difference. So for that also this pipe how should it be laid and all, that should be taken into consideration. Okay. Okay. Moving to the question, which of the following offshore structure is a mobile self-elevating unit? Jacket platform, artificial island, FPSO, or jackup platform?
Jack-up.
Yeah, correct. Because jackup platform was the mobile and self-elevating unit. Next question is mooring. Okay, mooring we have not done yet. Okay, first we'll understand what is mooring, then we'll come here. Oh, so many. Okay, see, what why I was discussing was mooring, na? Okay. FPS anyway. FPS is also, it is kind of floating production system only. And this full form is floating production system. So this came into existence after that drilling platform. So it will also consist of a hull. It will be supported by four anchors, uh, four circular steel columns, and it will be connecting with connecting up all the pontoons whatever we have, and it will be moored by means of catenary or taut supports to the seaboard. This mooring, catenary and all will come. So what I was about to discuss was mooring. What is mooring? So mooring is any permanent structure to which any vessel may be secured with lines or anchors. Okay. So mooring. Mooring is what? Mooring is some kind of structure. So to that structure, let us say some permanent structure is there, and to which this vessel will be secured with the anchors. So that is called as mooring. So that is one mooring, and then we have catenary and all. Catenary also we have to discuss, and taut support. Okay, mooring, I guess you understood. So there, other than this barn platforms, this FPSOs and all, we have spar platform also. It is also kind of similar to that ships and vessels, and it will be put in vertical position at the site of interest. It will be filled with iron ore, and it will provide you enough resistance against the lateral stability and all. So I'm not going to all the platforms and all. Now what I was saying was mooring. Mooring, anyway I said. So this catenary mooring, what is catenary mooring? Catenary is simply let us say what to say, let us say one flexible uniform non-stretchable substance is there which is suspended from its end. So that we are suspending one uniform flexible this non-stretchable, what to say that, let us say one wire or some kind of cable is there. Yeah, let us say one flexible uniform non-stretchable cable is there. So what we are doing, we are anchoring that at the mooring or the permanent structure. So this cable will take one curve or one shape. That shape is called as catenary. Okay, catenary is clear.
Yes, please.
Clear na? Okay. So mooring, catenary is clear. Then we have taut supports. But before that, this catenary, what I was saying, is a shape of the curve that is made when a flexible uniform non-stretchable cable is suspended from its end. Now it will consist of 100 millimeter diameter rope or cables, steel wires, or it can be of several materials. Okay, so sometimes chains are also, mostly chains only are used. So these heavy chains will be attached at the anchor. Let us rope, anchor, rope, chains, some kind of other materials, cables and all will be there. Okay, so that was catenary mooring. Then we have taut support, or sometimes it is called as semi taut support or semi taut mooring. So in case of deeper water, this mooring by means of catenary will not be feasible. Okay, because it will be only feasible for some shallow water depth. But when we are going for deeper water case, then what can happen, because of the heavy weight and subsequently affecting the design of the platform, we can't use the catenary mooring. So in such case, one lightweight rope is required, or some lightweight cable or something is required. So when the lightweight rope will reach the seabed, it is inclined with respect to the seabed. Anchor system, okay, I'll draw that. Let us say we have, this one is the water surface or sea water surface. Okay, and here is that assembly is there. So in catenary, what I said, it will be some kind of materials will be there, and it will be anchored like this. So it can be heavy steel, some polyester, or some other materials will be there. Here it is anchored. Okay, so this is catenary mooring or catenary. This shape is called catenary. And in taut support, while will happen, a light rope is just here. Here what we are doing, these are the heavy chains. So for shallower depth it is fine, but for the deeper depths we have to go for this kind of lightweight rope. Deeper depth. Okay, so in case of taut support, both the horizontal and the vertical loads are taken into consideration. Okay, I hope the mooring, catenaries and all are clear. Is it? Okay, it is clear. Okay. There is one picture also. Yeah, it will be much more clear here. So here you see there are heavy chains. This is the anchor. So there are heavy chains and all connected to some light chain. Okay, so this is the catenary mooring, where it will get this kind of shapes. But in taut mooring, it is lightweight rope and it is very firmly fixed. Okay, so this is the kind of taut mooring. This is kind of catenary mooring. Okay, this one is the mooring pendant. So mooring is clear, taut mooring, catenary mooring and all. Okay, so I'll go to the questions. Oh, this is done. Mooring by means of catenary is not suitable for what kind of water? Shallow water, high vertical load, deeper water, or none of the above?
C.
C, deeper water.
Deeper water.
Yeah, correct. Okay, so I think mooring is clear. Next is, the anchor should be designed to withstand both horizontal and vertical loading in case of which kind of mooring?
Taut mooring.
Taut moorings, correct. Because see, in the taut mooring, if you see, we have very firm mooring. So in this case there will be no horizontal movement also, or nor any vertical movement. So in the taut mooring only, the anchor is designed like that so that it can withstand both the horizontal and vertical loading. So the correct answer will be B. Okay, next question is, in case of catenary mooring, the anchor should be designed to withstand we are using chains and all, so only horizontal load should be considered to withstand. Okay, next is, an anchor pile is used in case of, again for anchoring we have different kind of anchors like surface gravity anchors, then box anchors. Okay, so in, let us say in case of surface gravity anchors, what will happen, will use anchors in floating systems or to provide extra support for stability in case of fixed systems. Okay, now in this surface gravity anchors, what is happening, the capacity is directly proportional to the weight of the anchor, and the friction that is developed between the seabed and the anchor base, let us say seabed is there and the anchor base is there, between that one friction will be there, and this capacity, whatever is capacity we need, that will be directly proportional to the this weight of the anchor and the friction that is there between the anchor bed and the anchor base, if you say the anchor base and the seabed. Based on that the capacity is decided. So only this surface gravity anchors and all is only restricted to shallow water depths because it has limited size and capacity. Okay, other anchors are box anchors. Okay, so in that box kind of thing will be there as the anchor. It will be a box filled with some material, some granular materials, which will be connected to the seabed. So what will happen in the box anchor, it will provide resistance against the stability of the box resulting from its self weight, because in that what we have the granular material. Okay, so because of its self weight as well as the contact area, the box anchor will provide you the resistance against the stability. Okay, so surface gravity anchor is done, box anchor is done. Then we have the granular and berm anchor. So in the granular and berm anchor, what we have, particularly it is similar to the like box anchors, but there will be one grill edge. No, that grill kind of thing will be there, and that grill will be buried under the rock or iron berm, like artificially we are creating at the seabed. Okay, and it will be connected with chains, and it will be attached to the grill edge, and thus it will provide one anchor to the connected system. Okay, other than that we have anchor piles also. So in case of anchor piles, some hollow steel pipes will be there which will be installed into the seabed, similar to the drill or grouted piles on shore. So this anchor piles will be used in case of fixed platforms. I gave one example of fixed platform was jacket platforms. So this anchored pile will be mostly used in case of the fixed platforms like jacket platforms. So the question is, an anchor pile is used in case of, oh, sorry, what happened? Array. Mhm. Yeah. So the question is, an anchor pile is used in case of mobile platform, fixed platform, floating platforms, or all of the above.
B.
Hmm. Fixed platforms, correct. Next is, dash is the name given to the shape of the curve made when a flexible, uniform, non-stretchable wire is uh, opposed from its end.
Catenary.
Catenary, correct. Okay. Catenary is the shape. Okay. Okay. Next is, vertical mooring is used in case of, vertical mooring means what? Vertical mooring means vertically we are anchoring it. So in what kind of platform do we use this vertical mooring? In case of tension leg platform.
Ten.
Tension leg platform, what is that? In tension leg platform, it will be consist of pontoons which will be supported by some steel columns. Okay, and it will be anchored into the seabed by means of pull by steel cables. Okay, so this vertical mooring will be used in case of tension leg platform. Next is, heave compensation assembly is provided in a vessel to ensure, this is simply simple. Anyone? Heave compensation
B.
assembly we have seen. Which
B.
one? B. Yeah, correct.
B.
For doing the, for understanding the relative movement, not understanding, for that assembly is provided to ensure that there is some relative movement of drilling cable with respect to the vessel. Okay, verticality of the drilling rate. So B will be the answer. Correct. Okay, that's it. I guess that's it. Do you have any other doubts for the week 7 lectures or something which you want to discuss? No doubts? Okay, let's stop.